Hello, I'm Paul Beckwith, and this is my feline friend, Shackleton. In this video, I'm going to talk all about methane in the Arctic. There's been some changes in the way that the Copernicus satellite data is displaying methane. In fact, the scales have changed, and that's been alarming a lot of people. So what I'll do is I'll talk about these measurements from Copernicus and what they've changed, and I'll relate it to the satellite data from another satellite called MetOps1, and I'll also talk about I'll also relate it to some ground measurements as well, some flask measurements that were taken in the Arctic. So the big question is, that people are wondering are basically, are we getting a methane burst, a significant methane uptick or burst in the Arctic right now? So I'll try to dissect that as best I can, and then we'll take it from there. Okay, so basically, this is my Facebook page. Okay, Paul Beckwith on Facebook. And this is a post. First, recently, Margot has done a number of videos, as well as Robin Westenra here. They've done some great videos and analysis or displaying of the observations of methane in the Arctic. So let's see what's going on. So this is data from Copernicus here. Okay, so this is showing recent data on methane. And with this particular scale, it looks like there's horrendous amounts of methane up in the northern hemisphere, where it tapers off down here to the southern hemisphere. Then what they did at Copernicus is they changed the scale. So this is a polar view now looking at the northern hemisphere, and you can see the different structure here. But the scale has been changed. In the previous version, with the previous scale, this was basically all red, and you couldn't decipher the details. And how did the scale change? Okay, as Robin shows, prior to December 11th, this was the color coding scale. Now you'll notice, so 2040, this is in parts per billion of methane. So here we have 2040, this is a 20 increment scale. So 1980, 2000 to 2020, 2040, 2060. So 2060 lumped up to this huge number here is all of this brownish color. Okay, now there's no way to tell what the methane value is in this range. We know it's higher than 2060, and we know that there is some data which goes right up to this huge number. But for example, almost all of it could be at 2080, and it would show up in this color, and we have no idea. There might be one or two data points. This is just the program would extract this type of number for this scale. Now, the new scale that they changed as of December 11th is, you can see they bumped up everything 100. Okay, so 1980 here, now it's 2080. 1860 before, now it's 1960. So they just bumped up the scale 100 units. Okay, so they just slid the scale up. And the maximum was 10,000. So they looked at that data, and there's a couple data points, maybe even one data point, maybe an anomalous data point, I don't know, which had a huge reading, and it's been adjusted here to a lower value. Okay, so that's the key thing. So why did they do that? So again, this is what we see now with the new scale, and this is what we had before. Now you really can't tell much here. So it's perfectly legitimate to adjust the scale so that you can interpret the data better. What the software should actually have have is the ability for the user to select the scale. Let's go the other way, for example. Okay, what if they bump the scale? If they bump the scale, so instead of bumping it up, sliding it up, so 1980 became 2080, what if they did it the other way? And 1980 became 1880, for example. Then what you would see, the idea of the color scales is to make it a plot very, very clear. So if they bumped it up, if they adjusted it the other way, all of this region here would be completely red. And in fact, you can see that if they adjusted the scale down even more, you could have the entire map red, and people would say, "Well, wow, look at all the methane," but it would be an improper depiction of the scale. Like, you want to have a scale so that you can discern features of what's going on. Now, when you're comparing a map to a previous map, you always have to look at the scale. You can't assume that red in a previous map is the same as red now. So I'm trying to get that point across, that it's a way of displaying the data. Okay, so let's have a look at, that's from this. Now this is, Harold Hensel posted this. So this shows you how the scales actually change. So this is what we had prior to December 11th. Okay, so you can see, this looks horrible for the amount of methane, and you can see, the methane levels methane is definitely rising, rapidly around the globe, and I'll show you some of the data, and in the Arctic specifically. But this map doesn't give you a lot of information because you can't decipher the levels in these regions too well, because it's all binned and it's all put into a high bin, color bin. Now, what happens is with the scale shifting, you can actually discern hot spots and so on. So you can't assume that the scale shift, this is not good news that they've had to change the scale, but it's not really anything nefarious that is being done. What it is it's a change of the scale in order to depict the data and give you more detail, if you like more structure. But what they should really do is allow the user to adjust the scale. But this would become maybe problematic when you're trying to compare what's going on now with what happened, say, 4 months ago or 6 months ago. So let's have a look at, let's close this and let's have a look at Robin's blog here. Okay, here we go, discussing a rapid increase in methane. Okay, so Robert gives a lot of good information here. My computer, I think I may have to get a new computer. This thing is being very problematic for me. So here's some images and movies of what the methane is doing on a particular scale, and scales given there. This is comparing it to some MetOp satellite data. This is at 506 millibars, about halfway up the atmosphere. And you've got the mean here and the range. And this is December 11th. Okay, so this is, in order to see how the Copernicus data, the best thing is to take data from all different sources and compare it, because there's such things as faulty sensors, there's such things as anomalous readings, etc. Okay, so this is Copernicus data. This is back to the MetOp data. Back in August, there were some spikes. Okay, remember, this number is picked out by the software. This is the highest pixel. This is the ppb of methane in the highest pixel in the whole map. And the satellite's measuring a whole swath. If it's close to a particular source, there can be a very high number. So it would be better to see the distribution here. It would be good to get information. Okay, 1 pixel is this high, but where is the next pixel? It could be down at the 2000 level, for example. We just don't know. here's the mean of the overall picture. And halfway up the atmosphere, the levels are obviously higher towards the poles here, and some high parts here. Okay, surface level. So there's lots of different graphs and depictions, and methane is obviously rising rapidly. And in the Arctic, we know it's rising even more rapidly because of the permafrost has thawed. There's also methane coming from the seafloor, et cetera, et cetera. Okay, look at the values over India and parts of China. Enormous values, okay, that have been there. Okay, so, and then Margot has done some movies on it and so on. But let's go and have a look at the data. So I was using Internet Explorer and I couldn't, I clicked on, this is the Copernicus Atmospheric Monitoring Service, CAMS, and I clicked on worldwide, and global forecast plots, it says click here, and I got nothing. Okay, what the heck's going on? So after a while, I found that in Internet Explorer, okay, I wasn't getting anything, but if I go to Google Chrome, lo and behold, everything worked. So this was a link that Robin messaged me, and this shows the new scale that's been bumped up by 100, and you can see the structure here. So you can just see how, where the hot spots are more clearly. With the old scale, it was all smeared and you couldn't really see any fine structure or detail. So when you're picking a color scale for a particular map, you do want to see the detail and fine structure. So they needed to do something and they bumped the scale up 100. Now this is not hiding anything, this is trying to depict the data better, but it does indicate that methane is rising rapidly. The overall levels of methane are rising rapidly. It's just you have to be very careful now if you compared it in the past, because you can't compare directly because the scale has changed. Now, how do you arrive at this? If this is the home page of Copernicus, there's all kinds of climate stuff on there, and the CAMS, the Copernicus atmospheric modeling, you can find from this link, or just Google Copernicus Atmospheric Monitoring Service, and you get this link. And then if you click on worldwide, in this case, this link here does work, and it brings up the charts, and then I click on methane forecast, and we get the methane here. Okay, now this is the total column. So Robin was looking at 500. Okay, and this is global, so let's go to Arctic. And this is the Arctic. This is December 11th. This looks like the old scale to me, right? And they actually have a setting here, North Pole, you can click on, and that expands it a bit more. So this is what we have, and this is Tuesday, December 11th. So this shows you the methane, and the levels are extremely high. It doesn't matter, and it looks like when I compare this to this, something weird is happening, because the scale is, this is the new scale, and this is the old scale. Okay, so North Pole, 500 hexapascal, which is about halfway up the atmosphere. And this is at the surface. So let's go to 5. Let's bring the other one to the surface too, actually. So let's go to the surface. Okay, and here's what we see here. Okay, so what you can see is you can get a picture of how the methane is spreading out in the atmosphere with different levels, and I'm going to have to continue. I'll continue talking since methane is such an important topic. People are very concerned about it. I'll continue in a second video. Thank you.